No worries. All right, folks. Hope everybody enjoyed the break. Now we're David Duffett had to step out for a minute, so he asked me to be your temporary MC this afternoon. Our next speaker up in this room is Corey McFadden. Corey's the president and founder of Veneto and has decades of experience on both the technical side and the business side of real-time communications. And she's going to talk to us a little bit about kind of human-centered product design. Take it away, Corey.
All right. Thanks, Jared. So the presentation is entitled creatively, Human Factors and Product Death Spirals. It's a little ambiguous, so we'll get into what that means in a moment. But I'll do the obligatory about me. My name is Corey McFadden. As Jared said, I founded a company called Veneto. We are a unified communications as a service company, so we have a UCaaS platform. It does all of the things that all of the other ones do, and some things a lot better, and some really cool new features coming down the road. My current role, it's kind of evolved a lot, but mostly these days I'm doing a lot of product architecture, a lot of sort of like project leadership work, but it also involves writing a fair amount of code. And that's it's a good way to keep your mind sharp, but also a good way to burn up your late nights. But when I'm not actually writing code, I have an interesting hobby that some friends in the room know about. So we've all, at this event, talked a lot more about our personal journeys and kind of got into things at a level, I think, that we don't typically at other conferences. So I thought I'd include a couple fun photos to give you a little personal background. But occasionally I'm able to finish a race in a car and do okay in it. So that's good stuff. Anyhow, so let's talk about why products fail. They fail for a variety of reasons, many of which become very obvious in hindsight. Sometimes even the best products fail to succeed because they're introduced too early or too late. That said, sometimes they fail, well, just because they're bad. That's mostly where we'll be looking. And thankfully, it's more entertaining there. So we'll talk about really what are human factors relative to the user experience, how to avoid a bad outcome, and then we'll get into the good investment side of things, where we'll talk about avoiding death spirals. And then I have a little case study, which is the thing that kind of caused this talk to happen. Dan and I were working on a project last year, and as a part of it, I was showing him this thing I did, and he's like, oh, that'd make a really good talk. And then as we got closer to the event, he says, maybe you should give a non-technical talk. Got in my head a little bit, but I leaned into it. It's really good, so we're getting there. Anyhow, so the most essential element of a successful user interface is that your software empowers users without being frustrating. And human factors in other contexts takes things like fatigue, environment, physical traffic flows in airports and other things into account. And their effects can actually be life or death with things like medical outcomes and the performance of, let's say, airline pilots. In software, it's a bit less of a life or death situation for the user, but it can be a life or death thing for the product. And in this context, human factors is kind of a broad term covering a lot of related and overlapping concepts, so it'll feel a little redundant as we go around through this. But essentially, the goal is their use is making your application easy and enjoyable for users to interact with. So we'll start with a quick listing of them. We have, I'm not going to read them aloud. We'll go through them as we go. But as you can see, again, they're kind of related and they overlap a little bit. But before we dive in, I always like to take a throwback session or a throwback slide and talk about some telecom history. In the early part of the 20th century, before many of us were born, AT&T was a monopoly utility inside the United States. It had a well-funded research and development unit called Bell Labs, manufacturing divisions like Western Electric, and lots of other business components. And I can say without exaggeration that this one company was monumentally impactful to the world we live in today. And just to put it in context, A short list of things that they are credited for would be the invention of the transistor, the laser, the solar cell, the Unix operating system, and the C programming language. And imagine, without these things, what would our world look like today? Who knows, right? Anyhow, I bring them up because they invested a lot of time and effort into studying human factors and how they affected the use of the telephone and the telephone networks. And as an example, let's look at how human factors apply to something like the telephone. Oh, crap, I had another historical tidbit I want to share. As an example of this, so it went on every level. So they considered human factors with physical product design, with network performance, with usability, and in ways we don't really even think about at this point. The best example I like to tell people that generally don't know this is the North American numbering plan. It was based on the population of the United States in 1947 and the rotary dials on the telephones. And the reason that, for example, area codes like 212 in New York City, 312 in Los Angeles were short to dial on the rotary handset was that they were the most populous cities in the United States at that time. So 212 New York, 312 Los Angeles, 213 Chicago. Those were the top three at the time. And they did this because they wanted to minimize the amount of time spent by humans dialing. And they did it based on not only the population, but also the study of the density of phone calls into those areas. So very holistic approach to this. And extended, again, beyond the physical handsets. We're talking about like the audio prompts that the phones produced, the congestion tones, dial tones, signaling, everything was considered. And, as an example, let's look at the design of this thing. What level of cognitive load is required to use it? Pretty low. Physically ergonomic, pretty much. Perceptual, how does that look? Labels are clear, makes sense for the most part. Accessible, well, not so much by our standards today, but at the time, accessible as was possible. Consistent, absolutely, very consistent across product to product. And aesthetics, utilitarian, but there was a little polish. It wasn't just square boxes. There's a little bit more work into that. And then as far as user interaction, there was error tolerance and feedback by way of those audio cues and signals we talked about. And as far as usability, learnability, I would say you probably couldn't just approach this and intuitively know exactly how to use it. But once you got beyond the concept of you dial doing this, then the rest of it became pretty straightforward. So diving in, cognitive load refers to the amount of mental effort required to process information. In this context, cognitive load generally refers to the mental effort needed by a user to use and understand a product. We divide it into a couple different categories. Intrinsic load is basically the problem itself. It's independent of how it's presented. It is the sum and substance of what we are doing. It can't be altered by design. Extraneous load is this is not necessary for problem solving, but it's imposed by the way that the information or the task is presented to the user. So good instructional design seeks to minimize this. Now, in a software application cluttered with too many features and buttons and options, it can overwhelm users and make it difficult for them to find the features that they need. So the third item is the germane load. This is the mental work that's required to convert short-term learning to long-term memory and creation of schemas and understanding in your brain and things like that. And that's kind of where you want most of the cognitive effort to be, not on the just understanding the problem itself side of things. As far as best practices go, this is relatively obvious, but it's important to remember, and that's why we're talking about it. Simplify user experiences and workflows as much as possible. Remove unnecessary options and features, use intuitive layouts, and provide clear instructions. Keep the interface and behavior of the application as consistent as possible so users can understand how it works, predict what's going to happen, and be able to move from section to section within your application with some consistency. The physical ergonomics in this context, obviously in the context of products, it talks about the physical aspects, right? But a lot of that translates to software. Interface design influences how users physically interact with the hardware. Keyboard, mouse, touch screens, haptics, as they navigate and use devices, which directly impacts the efficiency of their interaction. Perceptual covers the way users perceive, interpret, and understand information presented through a UI. It involves a lot of cognitive skills, ranging from visual, audio, and other sensory perceptions. So consistent design helps users make accurate predictions. Consistency can be maintained by color schema, typography, iconography, layout patterns. Overly complicated designs will overwhelm the user's perceptual abilities. So keep it simple, clear, concise, avoid unnecessary clutter within the interfaces. Try to maintain a visual hierarchy of your navigation and other structures. Try to have some logic to it so it makes sense. Use universally recognized symbols and icons to help users understand functions quickly without needing to think too much. Don't invent brand new iconography if there is something familiar you can use instead. It's a common mistake. And also, make sure to provide feedback. The users often don't know what the system is doing. Examples like highlighting on a button when it's clicked, showing a loader when a page is loading, or displaying some kind of success or error message when something has happened. As developers, we can usually guess what's happening in scenarios when this is forgotten, right? But it's still confusing and irritating. We know what's happening, but we're irritated that the developer didn't implement something, so we knew that, right? Imagine that amplified, and you can get closer to what the experience of an average user is in that situation, and it's not good. Accessibility, do not forget this. Screen readers will help people who are visually impaired or blind. Make sure all of your images, your buttons, your forms, etc., have relevant and meaningful alternate text, not the word placeholder copied over and over and over again. People with low vision or color blindness might find it hard to interact with the software if there's not enough visual contrast between the background and the foreground colors. Little things, right? Not everyone uses a mouse to navigate. Some people will use keyboards, especially if they have motor disabilities. So consider allowing key features to be accessed through keyboard-only shortcuts. And that extends into, really the functional, usable elements of things. You don't have to go crazy with it, but that is something that a lot of people forget. Automatically playing audio or video will disorient a lot of users, especially those who have sensitivities. So provide control so the user can play media if they choose. Transcription's great, not only just for people who have a hearing impairment, but also for folks who are just in a noisy or sensitive environment and don't want to have the audio coming through. So that's something that you can keep in mind as you offer features. It's not only just disabilities, it's also situational. And then the other thing is that consistency of navigation across your system, across your platforms, very important for folks who have cognitive disabilities. Not only is it good for regular users, but it's good for everyone. Don'ts, right? We talked about some of this already. Don't use color as the only visual means of communicating something. So having something change from black to red, for example, as an error condition, probably not good because you're going to have folks who don't have the ability visually to distinguish that. So do something else. Don't complicate your interfaces too much. We talked about the cognitive overload. Motor disabilities, that will prevent people from clicking on teeny tiny little buttons. So make sure that they're large enough to give people what they need. And then we talked about alternate text. And the other one that I like to remind people is that 3 times per second is about as much as you ever want to flash anything on your screen. More than that, you might give someone a seizure. We don't want to do that. Let's see. Consistency, very very obvious overall, but internal and external consistency, right? You want to be visually and textually and whatever consistent within your application stack, but also consider consistency with external applications. So you want your software to behave similarly to other familiar software so that users can figure out what they're doing. So for example, like Control-C, Control-V, these are keyboard shortcuts we expect to work a certain way. And if you make them do something else, probably not a good choice. And then from a consistent feedback perspective, you want to make sure that things do the same thing in all places. We talked about color schemas and things like that already. So consider font, layout, from an aesthetic perspective, arranging items on the screen so that they're organized and clean, have a nice layout, avoid an ambiguous sort of alignment structure where things are sort of free-form and haphazard. Psychologically, these little polishing touches add up. And if you want a successful product and not one that people look at and just sort of scratch their head and imagine some intern produced, these are the things you need to be considering. Okay, as a disclaimer, I went into our industry for examples of some applications that may express some of the poorer choices in these visual options. And I didn't want to offend anyone, so I went back to olden times with some of these to give you some examples of things that you don't want to do. So in this example, this application provides a lot of information, probably more than the user really wants to see. The iconography is, I think, odd. I don't know what some of the buttons do. I've looked at them a while, and I absent like running this old thing and getting a tooltip, I have no idea. There's a little hand up there. Does it grab something, or is it knocking on something? I don't know. Somebody's going to know this and tell me after the talk, because I'm really curious. So this is the only actual application example I'll include here, but as you can see, it violates a lot of the things that we just talked about. And obviously these were early days, and not a lot of these concepts were well understood, or at least well implemented. Error tolerance, we talked about a little bit, but it really just covers how the system handles errors and communicates them to the user. And some of the things that are not super obvious, but I'm talking about like input masking, so that as you're typing in phone numbers and other sorts of structurally expected inputs, you can actually visually cue the user to understand if they're doing it correctly or not. So that's always helpful. Error messages should be clear and concise. You want to tell the user what went wrong and how to fix it. Avoid anything generic. This is the dumbest error I see all the time, and it's very common, unfortunately. Users want to know what is going on, so tell them. Take the time. It's important. Let's see. So really, these are the goals. I mean, obviously, we've talked about a lot of this stuff over and over, but simple, clean, polished, intuitive, and if you can, make it flexible. But that's not always important. I believe in inflexibility sometimes. All right, so let's pivot and talk about what are project death spirals and how we avoid them. Because it's all about having a successful project, right? And obviously we talked initially about how to make it usable, how to make the user experience good. But how do we avoid not getting the product to market, or getting it out too late, missing a market opportunity or whatever? Well, we avoid some of these bad decisions. So scope creep, obvious. And some of these don't really look or seem like what they really are. Sometimes it's just pursuing too many things at the same time. Essentially anything and everything that can cause your product, your progress on a product, to significantly derail. And some scopes creep because project leaders and developers just don't know the word no. And that is a very important and powerful word. And sometimes it's no now, and sometimes it's no period. But either way, it's a word that has to be said more. And some projects just stop moving forward because people have problems making decisions. Sometimes there's an architectural direction that has to be chosen, and maybe there's a moving target with APIs or some other things in the industry, and you want to wait to see how the dust settles or whatever. Often that is a killer because some things are out of your control, and you just have to make a choice and move forward if you want to get something out there and get it into people's hands. And that is procrastination is a major issue. Staff churn, obviously, if you have a structurally problematic organization that has people turning over and your team is not cohesive, that is a project killer, obviously. So try to keep after your people, make them happy, try to keep people productive, and make sure that they're excited. And then the other thing is, as developers, we often encounter work that we did before, and things become difficult to look at after a while. We'll change the way we code the structures, our syntax, our methodologies, whatever. And it's very tempting to go back and change a lot of things. And things that are already working, that's not a good place to invest time. So the thing is, there's opportunity costs associated with everything you do. And, the trick is just to, hold back when you're looking at it, expending a lot of expensive time on something that's not going to yield a lot of good return. Okay, unfortunately, it's very natural to become excited during the early phases of a project's incubation. You have lots of great ideas for features, imagining ways to scale your project to global levels. The problem is if you're not disciplined with the way you approach some of these questions, you can get sucked into these tangents of development and thought that lead you to just getting nothing done. And global scale is great, and if that is the thing you're selling, and that's my caveat there, obviously start with that. But if that's not essential to getting the product out the door, do it later, or do it shortly thereafter. But good time investments. One thing I always recommend is benchmarking. Try to understand how your project works. Like, where is the time consumed? What are the delays? What are the friction points? And understand what the data payloads and the whole situation looks like. Because ultimately, these are the points where you can invest time and energy to refine something and deliver very obvious performance improvements very quickly and sometimes with minimal effort. And I actually have an example, and this is kind of what kicked this off. So we'll get into that in a moment. And in terms of optimizations, right? So once you've got your benchmarking data, and to get it, you chunk your project, divide it into sections, divide it into modules, whatever you need to do, all of the inputs, outputs. Consider the user impact, right? So the worst ones are the ones you solve first, right? It's very easy. And then ultimately, sometimes you get into little tiny improvements that will require a lot of time from an engineering perspective, but not yield a lot of user benefit. So to that end, avoid those diminishing return ones. That's important too. All right, the case study. This is the fun. So we have an application inside our platform. It's a call center wallboard. We call it our team panel. And the way it works basically is we have Asterisk as the backend, the telephony layer. And then we have an AMI socket that talks to Node, feeds it a fire hose of event data. And if anybody's ever worked with Asterisk, how many folks have ever worked with Asterisk in the room? Okay. Have you ever looked at Asterisk events? How many? Show of hands. Okay. They're very nice, right? Very, very concise, no, they're not. So the Node server processes those events as they come in real time and organizes them into state changes and other meaningful information to send to the users via WebSocket. And then you have user interfaces that are based on JavaScript. So that's the overall overview. And the reason that this was a thing that we had to tackle was that as the application scaled beyond hundreds to low thousands of users, we saw a large performance hit with the event traffic. So this is what the wallboard looks like. This is a live screenshot from a customer who has signed a waiver that allows us to take screenshots and such. It's not flashing, as you can see, but the iconography on the left gives you indication as to whether the user's on an inbound or an outbound call. You can see the caller ID, little timers and such. You can drag and drop. There's some interactivity. If you're a supervisor and you have this up on your window, you can mouse over and you can do monitor, listen barge, that kind of stuff. And it plots the day as you go on in real time. And you can set trending lines and other sorts of stuff. So we get a lot of good feedback on it. People like it. But it got to be really, really sluggish when we got into thousands of users. And the problem is the event payloads. So the idea was to look at all of the messaging and filter out the junk, reducing the overall bandwidth footprint, the amount of CPU and memory we're working with at the client, as well as at the node level, especially on the client side. Because believe it or not, there's a lot of really lousy old machines still out in production out there. And they don't have the resources that my laptop does. And it always surprises me that they're still operating, but they are. So the solution we came up with was a final state buffer. It wasn't really like I gave it a lot of thought. I just sort of sat down and did it one day. And I was talking with Dan, and we were working on a project together last year. And he said, "Oh yeah, that's good, that's good." It's about as excited as you can get out of Dan. But basically, what it does is it organizes the event flow into only the final state for a period of time. So in this case, I thought about the human eye, right? How many frame updates can we perceive per second? Obviously, if we're looking at animation, we're looking at video, it's 30, 60, whatever. We're talking about numbers on a screen, right? You don't want them to change that fast. So I'm thinking 4 per second. That is the number. That's probably the maximum we want to do. Anything slower than that, you're probably going to perceive a little lag within the application. Anything faster than that, you're not going to notice it. So that was my solution, my number. So let's talk about the way the application works. So this is the node application. It itself is modularized, right? So it has different components, and they all talk to each other using an inner application message bus, so event emitters, things like that. And the AMI handler receives the events, filters the ones that we care about, and sends them into the Asterisk event processor. The AMI handler does some pre-processing. It'll add some additional fields in there to kind of parse some things so we don't have to do it multiple times. So we'll get, like, for example, the extension or the SIP user out of the channel and throw that into another field, stuff like that. The event processor has functions organized for each one of the events that we deal with. So examples would be new channel, hold, and then there's a summary function that's called browser channel state handler, and that is run at the conclusion of each one of those event processes. So as you can imagine, as all of these events come in, we run the state change handler, and then we can see whether there's a state change of the current browser stack versus the new browser stack, and then if so, we push it out differentially. And it's basically 2 different JavaScript objects. And then we have another module that's the sockets handler, and it maintains different namespaces for different types of applications. And then obviously we send what we need to the wallboards and what we need to the user portal and things like that. So that's the overview there. I think I copied the text without changing it underneath there. Sorry about that. OK, so hopefully that's kind of readable. I don't know. This is an example of one of those functions. It's a short one, very simple, so you can just visually get your head around how it works. So the event flows in. It's called hold. In there, there's some fields that we expect to see, like a channel user, a channel segment, and then there's more, but obviously this function is not a good example. So what this one does is it simply turns on the hold state of that particular channel. Another example that's a little bit more illustrative is the new connected line. So this is something we get on a caller ID change and that kind of thing. So basically, you've got channel user, segment, connected line number, connected line name, the state description, and the state itself. And then we use those to update the underlying object, which is asterisk channel states. Then we compare that against the browser channel states, and then that's what that function does. So inside the browser state, the function is this method here called send, and that will broadcast the event within the application, saying there's an I/O event that needs to go out to the socket I/O. And we have within it this finalize milliseconds and finalize keys. So what I'm doing there is using 250 milliseconds as a number for the timer, and then the keys allow me to specify what the sort of field organization is to allow that to be updated more frequently as needed with things that are changing versus things that are, not. So that way, we're not building up this giant thing. So on the other side of that, in the socket handler on the right, we have the queue event, which is the event receiver for queue event on the left. And then what this is doing is then broadcasting this out to the namespace using this function called NSSendFinal, which is here. And what this one does is it actually destructures things using a reducer, and basically, where is it here? It is the, I like really short variable names sometimes. So O is basically the holder, which tracks whether or not, or what the latest message is for that thing. So O is the first key, and then K is the second key. So in this case, it's the, I think it was the queue and the user. Okay, so basically queue, user, and then the latest event for that, and it'll stack them up, as you can see, based on the set timeout here and the finalize milliseconds. So what ends up happening is that if this timer is not set, it runs it, sets the timer, and then we'll send it out at the end of it. And if there's more updates that come in the meantime, they'll get overlaid so that when the timer times out, it'll send it again. So that way, a continuous flow of events comes through. And, again, from a user perspective, it's only 4 times per second as opposed to a lot of times per second. So this is a sample of traffic that gives you an illustration of what the improvement did. So over a 10-second period, this was a larger customer. Every user, prior to the optimization, it was 221 kilobits per second of traffic to every portal user, or every panel user, rather. And it's not a lot of data in the context of video and some of the things we're doing today, but these are raw events. That's a lot of event traffic. After the summarization, you can see we got that down to about 6.9 kilobits, which ultimately was amazing. Created every effect we needed. It ended up solving our problem and got me here. So fun times. So the TLDR takeaway from this talk is the human factors are essential to product success. And it's very important for us to think like we are the old AT&T folks, back when they had all of those brains working on product usability, user experience, ergonomics, et cetera. Turn your head sideways a little bit. Look at your product and see what you can see that you didn't look at when you looked at it straight on. Because there are things there that can be improved, I'm sure. And then invest those efforts in places most likely to deliver tangible improvements. So by that I mean, don't waste your time on nonsense. Do not optimize things people don't see if they don't yield a measurable performance increase. And then, very importantly, amazing technology will fail when the user experience sucks. So don't let your user experience suck. All right, I want to thank everybody for sitting here and listening to me babble on, and to Dan and the ComCon team for having me. I think this is one of the most amazing communities. I've been in the space for a long time. As Jared said, a long time. I started with Asterisk back in 2005 or 6, and have been in contact and friends with a lot of the folks here for many years at this point, and it has been a privilege to have this be part of my life. And it's been a huge, measurably huge part of it. So I appreciate that. I appreciate you all. So thank you. All right.
Thanks, Corey. All right, we've got a couple of minutes for questions. Any questions for Corey? Tim's got a question. A microphone coming to you.
Yeah, I'd be happy to, Luca.
So I'm curious about whether you ended up moving CPU load onto your node server. Like, did you feel the pain there and just think, well, it was an acceptable cost?
Right. That's a good question. So the before and after of the impact on the back end, I didn't really observe anything. We were doing the browser state channel handler from the very beginning. It was only pushing the differential between the back end and the front end. It was just changing so fast that we had to throttle that, and that's really what it was. So the imposition of the additional timer at the topic level, I'll call it, because it's the sort of the base and then the key, that didn't really add anything too measurable. Yeah, Node is pretty robust as far as a lot of that stuff goes. As long as you're not trying to, write to the same thing at the same time. All right. Well, hopefully my code wasn't too terrible. So, all right, folks. Thanks again. I'll be around.